Yeah.
So thank you everyone for joining, and everyone is expert here, so I'm a bit anxious, but that's okay. Here today. I'm here to tell you a story about our migration to AWS and the challenges we faced and how we overcome them. But before I start, I'd like to know how do you guys are familiar with AWS? Who knows AWS? Okay. And that's okay if you don't know, but how about advanced networking, transit gateway? Okay, good, great. So, we have 1 hour. I also like to show you some demos, so I will be quick. If you have any question, just let me know. Long story short, we decided to migrate everything to the cloud. And as migrating a legacy system to the cloud, we faced several challenges. We lift and shift. We didn't create a new environment. But we couldn't lift and shift the firewalls, the security appliances we had. So initially we started using some virtual firewall. We used actually FortiGate, and we tried to use security groups and network access lists and so on to secure the environment. At the beginning, our footstep was very small, but we grow. Right now, we have over 100 VPCs. We have more than 20 accounts. And soon this environment has become very difficult to manage. I want to emphasize something. When whatever we did, you could do it with only AWS native services. And I will tell you why we chose to go with the Fortinet solution. Our environment grew. I remember that I was at the beginning. I see a production database with public IP and SSH port open to entire world. And that was not fault of anyone. The person who maintained the database is not a security expert. He just wanted to do his job, and we didn't have any VPN, so he wanted to SSH to his system. What else he could do? Also, we had many issues. For example, we established a VPN to a VPC, and then another team needed that VPN as well. So instead of reusing that VPN connection, we needed to establish a new one. So for this reason, we decided to design a central network architecture. But we had some problem. We didn't want to sacrifice scalability, reliability of the system. When you go with the central system, what happens if whatever you put in the center fails? An entire system fails. Nothing will work. Also, whenever traffic increases, this thing in the center should be able to handle this. And at the time, many technologies that used in this design weren't available. Technologies such as Transit Gateway Connect, AWS Gateway Load Balancer, and Transit Gateway has a mode called Appliance Mode. None of these were available, so the design was very challenging. Basically, what I wanted to do, I wanted to create 2-3 FortiGate firewall, establish an IPsec tunnel to the Transit Gateway. Transit Gateway, for the whom do not know what it is, it's like a big router in the center. When you connect things to these VPCs, VPN, these things can communicate with each other without any restriction. So, but IPsec has overhead, and we had a lot of issue, mostly with asymmetric routing. The traffic will be dropped by asymmetric routing. So we had designed, we actually had answer to all of this question, but it was not satisfying me. It was not satisfactory for me. So we improved the design by when AWS released a new technology. I will show it to you how it's worked. Also about the problem I mentioned. What we did for scalability, for single point of failure, let me explain it in the design. One additional note, we argued a lot about distributed system and central system. I was against the distributed system because in the distributed system we have over 100 VPC, and in distributed system you need to deploy firewall in each one of them, and it will be a chaos to manage. It will be, and the cost will be a lot. So also central system has its own issue. So we came up with a design. Just one thing between us, AWS has a service launched 2 years ago, AWS Network Firewall. I don't know if you are familiar with it. We can also use, for example, Fortinet IPS in that system. We also evaluated that for deployment briefly. And also Fortinet released security system CNF. Right? I think it's called the same. These two systems use exactly same design, and that we are using. And this is coincident. This is not no one copied design from anyone. It was interesting that all of us came to the same conclusion that what the best design is. So I think it's easier for me to explain here with the flow chart. So I didn't put it in the PowerPoint actually. So this is our network core system. I don't have time actually to explain all of it, but it's, as you can see, it's a huge design. It's a big design and it's complex. But the thing is, you deploy this once and it works. You do not need to change it. You do not need to improve it. You do not need to do anything. It just works. So the deployment is one-time thing. So this VPC, we call it inspection VPC. This VPC is where we host the firewall. Initially, we launched 3 firewall. Can anyone tell me why most of our applications are deployed in 2 availability zone, but we deployed the firewall in 3 availability zone? There was a specific reason for that. Can anyone guess what it was?
Yes. Yeah, because of the auto scaling.
You can limit auto scaling growth to 2 availabilities. Actually, the reason was not a simple one. You know, AWS has a policy, so every availability zone be used. So whenever you create a new account, the availability zone, real availability zone, randomize, and it will give you a number. For example, for me, I have availability zone A, B, and C. This correlate to availability zone A, correlate to availability zone 2. But for another account, availability zone A correlate to availability zone 3, real availability zone 3. So since AWS randomized this, we deployed the firewall in 3 availability zones, so we don't have cross-region traffic, cross-availability zone traffic. This has 2 problems. The first problem is cost, which most of it reduced by AWS. The second of it, of course, is delay. In Frankfurt, between availability zones, we have 15 to 20 millisecond delay, which is too much. So we deployed firewall in 3 availability zone, and as you can see, we have a lot of subnets and the routing table. The reason that we have a lot of subnets is because we needed to manage the traffic. And each subnet has a dedicated routing table assigned to it. And for each availability zone, it's exactly the same. So I will focus on this one. So the firewall itself has 3 interfaces, one management interface. We use a split VDOM. So we separated the management plane of the firewall. It's connected to this subnet, and we have a VPC peering which connects our management subnet, management VPC. So the management of the firewall is completely out of the grid. We have a public interface which is connected to the internet, and we have internal. We have 2 other subnets which I include. The only important thing here, each subnet has its own routing table. So, don't mind that I have 3 transit gateway here. Assume that we only have 1. So, this we have 2 terms in transit gateway. We have a transit gateway routing table. We have association and we have propagation. When you attach VPC or VPN or whatever, we have transit gateway attachment, peer attachment. We have different type of attachment. When you attach anything to transit gateway, you should associate it to a routing table. And what is propagation? When you attach a VPC to a transit gateway, you can or cannot, may not actually propagate the VPC CIDR to the routing table. So you do not need to do the routing manually. So here we also have 2 different routing tables, which I will explain what they used for. The inspection VPC is associated with this routing table. We call it inspection. And a spoke VPC, whatever VPC that we want to inspect traffic, associated with this routing table. I want to explain something. This is designed to inspect 3 things. VPC to VPC traffic, VPC to internet traffic, and internet to VPC traffic. Inbound and outbound internet. It is not long from last year. It's possible that we can also inspect subnet to subnet traffic inside the VPC, which I didn't want to do that because my main goal actually was to control internet traffic. So now let's actually trace traffic. Let's see how it's work. So I have 2 VPC. They are connected to this transit gateway. VPC A wants to send traffic to VPC B. So let me fix the destination. That doesn't matter what the IP is. The only important is the IP is in the VPC side of VPC A. Please guys, if something is not clear or you don't know any definition or concept in AWS, please go ahead and ask me. I'd like to explain it to you. So a packet is created, it wants to send to VPC. So VPC A does send our internal private IP that used in what we are using to the transit gateway. So it sends packet directly to transit gateway. Since this VPC is attached to a spoke VPC, it will land here and consult this routing table. In this routing table, we have a single route, one route. It says send everything to inspection VPC. So it sends packet to inspection VPC. Which subnet? For just simplicity, I assume that we only use availability zone 1, so it's more easier to explain. So transit gateway can, when you associate VPC to transit gateway, it asks you which subnet do you want to connect to the transit gateway. So here in this design, we have a dedicated subnet for transit gateway connection. Because of that, the packet goes here. And it has its own dedicated routing table. It has one route. It says send everything. It has a default route to this VPC endpoint. So what is this VPC endpoint? AWS created something named AWS Gateway Load Balancer. It's created is this so we can bring appliance to AWS. It's fixed two major issues. First, it fixes the asymmetric traffic, which, believe me, it's a major pain when you design in multi availability environment which the firewalls are separated. The second thing is it can take care of the scalability. When your firewall scale, so in the old scenario, if you remember, I mentioned I wanted to use IPsec to connect to the transit gateway. So in that case, scalability was too hard because every time I deploy a new firewall, I needed to establish a new IPsec tunnel. But here it's easier because AWS Gateway Load Balancer take care of this. It has a target group, and the target group is the firewalls basically. And what is the VPC endpoint? It's like a magical portal. If you send anything to this VPC endpoint, it sends it to the Gateway Load Balancer. If the Gateway Load Balancer wants to send out anything to the VPC, to anything, it sends out from this VPC endpoint. So it's, as I mentioned, it's like a magical portal. We can send traffic to and receive it from. And one point, we have several type of VPC endpoint. You probably maybe read it. We had interface type, we had gateway type, but this is the new one. This is the Gateway Load Balancer type. So this is send packet to the transit, to the VPC endpoint, and VPC endpoint is like a magic portal. Send it to the Gateway Load Balancer. Now, we establish, whenever you add a target to the firewall, you establish a GNIV tunnel to the firewall. So when you deploy the Gateway Load Balancer, it has interface. You will attach it to the subnet, and the firewall also have an interface here. So basically between these things we establish a tunnel. So it has a tunnel, it chooses one of the target, it sends it to the firewall. Now in the firewall we can inspect the traffic. We can, if it's matched with our security policy, whatever we want to do in the firewall, if it's allowed at the end, it will send back to the Gateway Load Balancer. And what Gateway Load Balancer does, it sends out from this VPC endpoint. I said it's used for send packet in and packet out. Now this subnet also has a routing table. This routing table says send everything to transit gateway. So as I mentioned, it's a bit complex, but you deploy it once. It sends packet to the transit gateway. since I mentioned the inspection VPC attached to this routing table, it will consult this routing table. But also not only inspection VPC attached to this routing table, but every VPC that we have also propagated to this routing table. So it has route for every VPC, also including the VPCB. And it sent traffic, come on, to VPCB. I don't think I need to trace the return traffic. I just wanted you to see how the traffic is inspected. Do you remember I mentioned we had two problems, two major issues to migrating to use this central architecture? One of them was reliability. How we handle reliability? Actually, we deploy multiple firewalls, we have process, we make sure the firewalls are not having any issue, but what if there is a failure? Everything will be done. So we design a bypass plan, and the bypass plan is very easy. With a simple click, I can bypass one VPC or all of them. How? Again, do you remember I mentioned that every VPC are propagated here? I change it and propagate VPC also here. So when the traffic comes, it has return route and it's directly sent back to the VPC. This way we can easily bypass the firewalls. Also from bottleneck, we try to use auto scaling group to deploy more firewall if there was a problem. I don't believe it will happen for our environment, and it has some complexity to deploy, but yeah, we did it anyway.
If you have this bypass installed or prepared, and once in a while you have to test this. When is a good situation, or when actually do you do the testing for this kind of stuff? Actually,
we only test it from the beginning, and we use Terraform to deploy the code AWS configuration. We just need to actually uncomment some codes, so it will be completely bypassed. It's very easy to deploy, but we haven't tested after the deployment, only initially.
Okay.
But yeah, it sounds logic. It's work perfectly.
Maybe one question, which kind of security level have you established on your firewall? Is it layer 4 up to layer 7? It depends probably on the destination part or IDS.
Actually, at this phase, we haven't enforced anything because we use the system which there is a lot of connection, and as usual, we all have the experience. No one have any information about it. So we get and bring every system behind this firewall. And we not yet enforce the traffic, but we cannot go up to layer 7 because the firewall doesn't support it basically. And furthermore, we need SSL inspection to be able at least have some meaningful IPS protection, upper layer protection. And this proved very challenging because of they use many different certificates for different. They use MTLS, and I haven't decided yet how we are going to do. But I don't want to lock the traditional put just policy there. So what we are going to do? FortiGate will integrate with AWS. When you do integration, you can read every tags from every resource. For example, assume that I want allow an EC2 machine, a VM machine to the internet. I do not want to go there and create a policy for this. So what we do, we say that to the team responsible, We say to them, put, for example, internet tag to every resource that you need them to access to the internet. And by this simple action, they will get access to the internet. And for other thing, probably we are going to allow everything between int and test environment. One of the reasons we deployed is to be able to separate these environments. We have QA, test, int, and prod, and we have also CD environment, which is completely separated. This is not managed by this. And we mostly like to focus on the inbound internet.
So basically you're using the AWS connectivity on the firewalls for tags as dynamic address objects.
Yes, good.
To simplify your policy,
Yes.
to simplify your policy, we have the scalability to deploy further.
Exactly. Also less work for us. So
Is this the regular FortiGate VM or the CNF?
no, it's a regular FortiGate. When we deployed this, there was no CNF. But CNF is also used the exactly same design in the inspection VPC, but it doesn't use the transit gateway. It uses this magic portal I mentioned, VPC endpoint. I will show it to you how it works inside the VPC that you can deploy. Also, AWS Firewall works the same. Before I go, because I do not want to bore you, let me show you some stuff, from real environment. So, as I mentioned, we have a dedicated account. It will route every traffic. Here in transit table, transit gateway routing table, as I mentioned, we have two things. We have association and we have propagation. Association is when if we associate a VPC, for example, to transit gateway, traffic will be managed by this routing table. Propagation is actually, for example, I have one VPN here, which is propagated here, which means that every route learned by this VPN, which I think we have BGP, will be automatically inserted to this, there is no route anyway, to this routing table. So, gateway load balancer is a type of elastic load balancer. We had elastic application network load balancer. It's a new one, so it's in the EC2 panel, not the VPC panel. So in the load balancer, if you can see here, we have a gateway load balancer. Sorry, I cannot make it bigger. So it's like an ordinary, I mentioned we have 3 connectivity to the inspection VPC. So these are these 3 interface that you can see here. Listener, I will show it to you, and we have integration with the VPC endpoint service. This is the magical endpoint that I showed to you. And in the target group, I have the firewall. I removed one of them for testing, for redundancy check actually. Let me explain it to you how it works. So if, for example, we want to do a maintenance on one of the firewalls, First, we deregister from the target groups. Then it goes to the draining stage. You can configure the draining stage. For us is 300 seconds. Then in this draining stage, no new session will send to the firewall, and after draining stage, it will be completely removed from the system, and you can do the maintenance. But the thing I wanted to show you, this is the port that Guinea used. If you can see here, this is the protocol used. And finally, this is a VPC endpoint that we are using, and it has a service name. So I'm using the VPC endpoint in for many purposes, not only in the inspection VPC. As I mentioned, it's like a magic portal. So if you send traffic to this portal, it goes to the firewall. So I can give it to my customers, I can give it to my partners, I can give it to another VPCs. And this way I can connect them to our network via the firewall without needing VPC peering, transit gateway, anything. Just they can send traffic to this VPC endpoint, and they can reach our network. So whoever has this service name can have this portal. But it is not like that we have a security risk. Whoever connects to the system, we need to approve it here. Okay, guys, any question?
So you need some sort of connectivity to get to this magic endpoint?
Yeah.
Okay, it's not that it's on the internet.
No. It uses something called AWS private link. It's on the base of AWS network, and you are not limited to only one region. For example, you can deploy this in the US, in the, I don't know, APIC, I don't know, where anywhere you need. So let me explain something quickly, then we decide we continue with this or talk about the ZTNA. So this was about the VPC to VPC. How about the internet connectivity? Mm-hmm. So this is our spoke VPC design. Typical spoke VPC design. I don't know, did you know or not, or even you work with this. This is internet gateway. If you want connectivity from the VPC or to the VPC to the internet, you need to have one. But something that many don't know, that you can attach a routing table to this internet gateway. And by this way, when the internet traffic comes, instead of using this to the service here, we send it to this magic portals. And what happens when we send them to this VPC endpoints? It goes to the gateway load balancer, goes to the firewall, checked, back to the gateway load balancer, and back here. And when it back here, every routing table in AWS has a default CIDR of the VPC as a local. It means in the local in the VPC. So it has a route to go to whatever the destination is. It could be AWS LB, application load balancer. It can be EC2, whatever. So when the return traffic comes, every of this availability zone has a routing table. Because of the redundancy, we deploy multiple VPC endpoints. So the traffic, when they want to send back the traffic, they have the routing table again to this gateway load balancer. It goes to the firewall, check back here, and here we have a default route to the internet gateway. So this is how we can inspect the traffic. This is how AWS Network Firewall and CNF deployed. They don't use transit gateway. They just give you the service number. You attach the service number. You create the service number in your VPC. They approve it, and then you go. You just need to send it to this, and it will be inspected by the firewall.
So then you actually have a kind of a mixture of a distributed environment and with a centralized inspection VPC,
Yeah.
which gives you the scalability then.
Yeah, you of course this is the option you can go. You have routing tables, and you can play with this routing table. So it's simple routing. If I send this route to the ENI of a firewall, I inspected this locally.
Mm-hmm.
If I send it to the VPC endpoint, I checked it by the inspection VPC.
But again, right? You use the CNF firewall there.
I haven't.
You haven't.
We have our own firewall. So what the CNF is, the CNF, you don't have this inspection VPC. This is hidden from you. You don't pay for firewall, you don't pay for anything. This is created in a Fortinet environment, Fortinet account somewhere. So when you only create this VPC endpoint, when you create this VPC endpoint, you can send traffic to the CNF by this VPC endpoint. Then it's on the cloud. It will happen. You are not responsible for availability. You are not responsible for throughput, performance. Then when they check it, you can have a portal that you configure the firewall. It's the same, exactly same as FortiGate portal. When it's back, then it goes to your resource.
It really makes it easy for, let's say, not too technical savvy customers to consume an enterprise grade firewalling service.
Yeah, exactly. Also, it's very costly.
Is it?
costly?
Yeah, it cost us 55,000 just for licensing and maintaining this inspection VPC.
This inspection.
Yeah.
VPC.
This gateway load balancer costs you in two ways. Every attachment that you have, every VPC endpoint that you have, you need to pay per hour. Also traffic, and traffic is not just bit per second. Every session you need to pay. So also transit gateway attachment, traffic, the EC2, everything. So inspection, it's cost us 55,000 per year. Okay, any question?
No.
So we can continue to discuss about it, or we can go and we have how much time we have left? I think 15 minutes.
15, 20 minutes to do ZTNA. You'd like to understand a bit what Unzer, what Hooman built for ZTNA. That and what you built for ZTNA was before that, correct?
Yeah.
That the big solutions to build after.
Yes.
ZTNA is when Corona happened.
Exactly. For ZTNA, no one argued because everyone knew it's needed. But for this, we had many argue. We checked this with the AWS team. We checked this with Fortinet team. We checked this internally, and also for cost evaluation. By the time there was no CNF, but we also compared this with the AWS network firewall. So it takes a lot of time to deploy it.
I think nowadays, and especially since last week with the whole complexity of the transit gateway and transit gateway attachments can be mitigated with Cloud WAN. And now maybe you have followed the reinforce that you have now policy-based inspection offload in Cloud WAN, where you get basically all your routing set up as a kind of managed service.
No, I'm not aware of this, but CloudFront is a CDN, so
Cloud WAN.
Cloud WAN.
Yeah.
Yeah.
So it's basically a managed transit gateway load balancer endpoint, and it enables you to basically do that on a global scale, because you're basically using the AWS backbone as a transit
Also, you
for
can
information
segment
traffic.
your network, for
Yes.
example, yeah. But it's at the back end, it uses this transit gateway and different routing table. So
Yeah,
it will deploy
it's
this.
like CNF. It is. We're just trying to make it easier to consume because that is elaborate stuff.
Yeah. But also Cloud One is good, I think, good for the one who has a global footprint.
Or SD-WAN like Fortinet, and you can attach really with high bandwidth into
Okay.
even higher bandwidth in transit gateway because you can connect tunnelless like up to 100.
I heard that.
Just a quick one. And in the end, the decision to go central or decentralized, was it
So we decided to go central if there was any problem, if we feel that the application is very important, that we needed special care. So we choose a midway, not either of them. So we are going to central for an entire system. For some application, we might use a distributed system, and it can be easily handled with a routing table. So, no further question?
Is it really 15 milliseconds latency between availability zones in Frankfurt?
Why is that only?
Not 15. 15 and 20.
Between 15 and 20.
That's what.
1.5 milliseconds.
That seems like
Really odd.
a lot.
I can show it to you, actually. It was awful. So, this is one of our test machines we created for testing the bandwidth and redundancy. I don't know where it is. Let me see. So it's in 1496. Yeah, this is in availability zone 1 at this point. I have another machine. This is in another availability zone. Let me tell you which exactly. It's availability zone 1B. So I just simply ping it.
I think it's skip the minus T.
Oh yeah, but I think it's also. I just thought that I'm in the Windows environment. Sorry. So
That's half a millisecond.
yeah, I'm pretty sure I tested that last one. It was more. Maybe it doesn't go through the firewall. Maybe that time it goes through the firewall, and this one that added today.
Faith enabled is restored.
Yeah, actually, I was thinking of opening a support ticket for that.
License.
Also not. I need to check it myself because it's interesting for me.
of hardware.
Maybe this delay is introduced by this design.
But it's a design
Yeah,
to loop.
yeah. So it's a lot of added since the direct connection is less than 1 millisecond. If adding firewall at 15 milliseconds, then it's a problem.
Yeah, you get a few milliseconds for transit gateway and adding the firewall and the gateway load balancer endpoints, but not like 10.
Yeah, that's a lot. I
That
agree.
would be, please open a support ticket for that. That is not normal.
So let's talk about the TNA. Another problem we had, people needed to connect to this workload that we created in AWS. For both using this, not all the applications are public, also managing this. So initially I didn't want to create a TNA, this was not my intention. But two reasons happened that we actually created the TNA without we wanted. First, we acquired several companies. We expanded our offices from 2 to 7, and we needed a way that people connect to this environment. The second was, it was a Corona time, most people are working from home. We also needed a secure way to connecting them. So I thought that instead of securing our office network, we only deploy VPN access. So anyone wants to connect to the environment, they should enable the VPN. That doesn't matter, they are at home, they are at office, they are in the coffee shop. So wherever they are, they need to connect the VPN. So VPN has 4 pillars. The first pillar is you need to assume that the underneath network is non-secure, and you need to secure transport. This is the one. The second is authentication. Now we are using Azure, but by then we are using Okta. That doesn't matter. We are using SAML authentication. And we are using both username and certificate for machine to authenticate users. And on SAML we have multi-factor authentication, so users are securely authenticated. The third pillar of the TNA is less privileged access. So it was a challenge. Why it was a challenge? Because we had some clients which didn't belong to Active Directory. We had Mac OS, for example, they didn't have Active Directory. And because we merged from several companies and we had different domain and some computers are not belong to the domain, 40 client does have a module called SS sorry, I forgot. Single sign-on mobility agent, SSOMA. What this module does, it connects to FortiGate Authenticator in the back and collects your information, the group membership from the Active Directory, and send it to the firewall with FSSO. So we couldn't use this. Also, since we couldn't also use Active Directory to collect this information, we used several methods. We used syslog actually to extract the IP. But now the system is like that. When you connect to the VPN, firewall knows all the group membership you are in. So we have RBAC groups, which we manage the authorization, access authorization. So if you are in that group, you can access to a resource. If you are not, you don't have access to the resource. So easy as it. So for giving access, we simply add you to the Active Directory group. And fourth pillar is security posture. Security posture, we haven't deployed this yet because of not technical reason. And but I want to show you the demo at the end, how it works. I don't know, you'll probably see it, but maybe not in the beginning environment how it works. Why we didn't use web access? I don't remember by the time that we deployed the system there was a web access proxy or not. So you guys probably use web access proxies to connect to the services. We are also going to use this in the limited capacity. The reason is there are some people that it's easier for them to just open a web browser and access to a resource. But for most people, VPN I think is more usable. This is also has a longer story. I don't want to bore you, but it is now like this. So we have two FortiGate firewall. They are connected by Transit Gateway Connect. It's a GRE tunnel basically to the Transit Gateway, and the traffic doesn't pass the firewall because it's connected to the IPs are propagated here basically. And when people once we are using DNS load balancer basically, people connect to one of them, and with that they can connect to internal network. So, and we are also using this for SD-WAN hubs, but this is nothing this is not something I want to go to. So let me open the system that I need. So this is one of the firewalls, just a quick pointer. So if you see the users, we have these groups which are transferred to the firewall from FSSO, and we have the IP address. And in the policies, each policy has an RBAC group. So if you are in the RBAC group, you can access the resource. This is our EMS. This is between us one of the worst things that I see from the FortiGate. Is terrible product from the quality, full of bugs. So this is my endpoint here. If you can see here, I have 3 tags. I want to work with AV. What is AV means? It means that I have activated an up-to-date antivirus. So we can create tags as many different criteria. So I created one for AD. I just wanted you to see the rules you have. The one I'm using it uses the Windows security and Windows Defender's enable. So I can have Active Directory membership, antivirus, certificate, file, IP range, logged in domain, on Fabric OS version, and you can see it goes on common vulnerability. I can see if the device has vulnerability, critical vulnerability, it doesn't allow it to connect to the network. Firewall threads, 40 kilobyte version, and I have it for different operating system. And the one I have is AV, which means that I have active and up-to-date antivirus. Windows security is enabled. Now if I go to the firewall policy, in IP and MAC-based access control, I will add this tag, which is read from the EMS. I just add it here. Now, I ping this machine. As you can see, I can ping it. Then I go and disable my antivirus. I just disabled it. So let's wait a few minutes because it takes some time until it syncs with EMS, then EMS sync with the firewall. It's 3 to 4 minutes. So if I get back to my endpoint, the AV tag is gone. Let's see how many times it will take until I lost connectivity. So usually 40 clients sync every minute with EMS, and EMS sync every 3 minutes with the FortiGate. So in worst case scenario, we have 4 minutes delay.
Any question in the meantime?
No, it's gone.
Yeah. No meantime.
Now I simply enable my antivirus. So I wanted you to see this is a live system. So if the circumstances change, it reacts to my situation.
Question to the Fortinet folks. Is there also possibility to inspect Mac machines for that? Or integrate with Jump or
Yeah.
something like that?
It was Mac.
Yes.
Mac, iOS, what was it?
Android, Linux.
Android and Linux.
If I do a refresh here, the refresh is
Sorry, Hooman, I didn't get it. How do you authenticate the other companies that are joined to your company that are not in
everyone wants to connect to our network should have a user in our domain. That's it. So AV tag is back, and I have my connectivity. Without doing change, it's a live machine. So for your question, so we have also Mac machines. So I don't see anything that it says managed by Jamf, but we can check certificate because when you enroll in Jamf, it will create a certificate in profile with you. But it can definitely check with the Active Directory. Some machines have less item. For example, I think iOS has the least. And Windows has the most. Okay, gentlemen, any questions?
Any question before we do a break, correct? Yeah.
Really confusing.
Sorry?
You're the master of disaster.
No, but I can recall it was a break now before we
Yeah, there was
a break to order the food and pizza.
No, that's already done.
Ah, no, that's on. Okay, sorry.
All done?
No
No question?
No question? And we do a break, 10, 15 minutes, let's say 10, 35? 35? And then we have the next session with Christoph,
Yeah.
Master of Disaster.